Very good evening to all of you. So we'll talk today now a little bit about the solar family. We have had a little bit of discussion about the universe, and as we have seen, our picture of the universe as at present is in terms of a supercluster of galaxies. The superclusters in turn are subdivided into clusters of galaxies. The clusters are of course made up of individual galaxies. The individual galaxies contains billions of stars, and out of these billions of stars, out of these billions of galaxies, there is one particular galaxy, the Milky Way galaxy, that contains one very important particular star that we refer to as the Sun. And this Sun has a family of its own that we refer to as the solar family. And it is this family that is most important for all of us here on the earth, because of the reason that in spite of the fact that it is a very, very tiny part of the universe, it is just a speck in the Milky Way galaxy, which in turn itself is just one of the billions of galaxies that are present in the universe. In spite of all this, this particular part of the universe, this very tiny part of the universe, is of immense interest to mankind, because one of the planets, one of the members of this family, our planet, the Earth, is having the form of life that has originated and that is being sustained over here. As at present, we have not been able to detect a similar form of life on any other part of the universe, though of course there are a number of speculations that there may be life of this kind in other parts of the universe. But because of this very special reason, the Earth containing the necessary conditions or having the necessary conditions for the origin of the life as well as for the sustenance of life, this solar family becomes of prime importance, of immense importance to we, the mankind. We all know now that this solar family has the Sun as its center and its primary member or as the head of the family. And there are 8 planets in the solar family. Of course, the figure earlier used to be 9, but since 2006, the 9th planet Pluto has been relegated to the status of a dwarf planet. So we now talk of 8 planets. Now, of course, there is a lot of discussion going on, and we may soon have to revise again our ideas about the status of Pluto. But at present, we'll say that the solar family has 8 planets, and there are some other minor objects in this that are referred to as the asteroids and the comets. The asteroids in turn give rise to what we call the meteors and the meteorites. And this collection of all these objects that taken together is referred to as the solar family. The 8 planets that are listed in this family as at present are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune. So what we will talk about will be briefly about the details of the information that we now have at present about the Sun, and also a little bit of information that we have about the different planets in the solar system and some other interesting features of the members of the solar system. And of course, a little bit in detail, we'll talk about the Earth in particular, because that is where you have all the origin of life. Now, there are several common features that are associated with all these 8 planets. That is why they are referred to as the main 8 members of the solar family. So they do not have any light of their own. Whatever the observed glow we have for any planet, that is because of the reflection of part of the sunlight that is falling on them. They all revolve in orbits around the Sun because of the force of gravitation between the Sun and the planet. So all the planets, because they are revolving around the Sun under the same force of gravitation, and they do not have any light of their own, they are all characterized as something common. They are given the common name planet, and they are the more important, the more significant members of the solar family. All the planets orbit the Sun nearly the same plane. That is also interesting. the plane of the Earth's orbit around the Sun, that is also the plane in which, very nearly the plane in which all the planets revolve. Pluto was an exception to this, and that is another reason why it is not at present being regarded as similar to the other planets. And if we take the north pole of the Earth as defining the north end side of the solar family, all the planets orbit the Sun in the anti-clockwise sense. So these common features, they link all the members of all the planets of the solar family. Then, based on their, say, individual characteristics, the planets have been classified into two main groups. So we have with us now detailed data and information about all the planets of the solar system. On the basis of that, we have been able to classify them into two broad categories. The planets Mercury, Venus, Mars and Earth, they are referred to as the inner planets. The other four planets, Jupiter, Saturn, Uranus and Neptune, they are given the name Jovian planets, just to say indicate that their basic characteristics, all the other three, are similar to those of the characteristics of the planet Jupiter. Then the inner planets consist mainly of metals and rocks, and all have average density of 4,000 to 5,000 kilogram per meter cube. So that means 4 to 5 times the average density of water. The Jovian planets, on the other hand, they mainly consist of gases and ice. They have average density of 1,000 to 2,000 kilogram per meter cube. So the average density of the Jovian planets, that is much smaller than that of the inner planets. The asteroids are small objects, relatively small objects, that are found mainly between the orbits of Mars and Jupiter, but their characteristics are more similar to those of the inner planets than of the Jovian planets. Let us say now look at the different members of the solar family in detail. As I just mentioned, it is the Sun that is the main or the central member of the solar family, the head of the solar family. So its mass is very nearly more than 99.8% of the total mass of the family. That means all the other planets, they are having a very insignificant mass compared to that of the Sun. That is why we say that it is the Sun that can be regarded as some sort of, you can say, center or fixed point around which all the planets orbit around. Of course, because of the mutual gravitational attraction, we should say think of both the objects. When there is a gravitational attraction between the two objects, we should think of both orbiting about their common center of mass. But because this mass of the Sun is so very large in comparison to that of the other planets, we can say think of the Sun itself as being the center around which all the planets orbit around. The diameter of the Sun is about 110 times that of the Earth. So the volume will go up because it is, say, nearly 10 to the power 2 times the diameter of the Earth. The volume will go up by a factor of 10 to the power 6. So a million times, more than a million times the size of the Earth. That is what the Sun would be. The average density, however, because the mass is very large in comparison to that of the Earth, but the volume is larger by a still larger factor, the average density of the Sun, that becomes less than the average density of the Earth. The average density of the Sun is just about 1400 kilogram per meter cube. The main composition of Sun, of course, is hydrogen and helium. And this is because of the fact that in the initial stages, when the Big Bang led to the formation of the, you can say, origin of the universe, the initial stages, the constituent particles, the elementary particles, they combined together to form first the simplest of the atoms, hydrogen and helium. And this process itself took so much time that even at present we have very little amount of the other heavier elements taken as a percentage presence in the universe as a whole. The stars and the Sun, which is also one of the stars, they are mainly composed of hydrogen and helium. The cause of energy release from the Sun, that has been debated upon for a long time. A number of suggestions were put forward, but it was finally, you can say, the understanding of the details of the nuclei and the nuclear reactions that led to the suggestion that it is the nuclear fusion of hydrogen to form helium that is the source of the energy that is being released by the sun and the different stars. So we do not now think of any other reason as being the reason for which the release of energy by the sun and the stars. We primarily now believe that is the fusion of hydrogen into helium that is releasing all the energy that is available from the sun and the star. Now, of course, the sun is releasing a tremendous amount of energy and is burning its hydrogen fuel at a tremendous rate, but the overall estimate, the hydrogen fuel that is still available will last it at least for another 5 billion years. So therefore, there is no immediate cause of worry as far as the release of energy from the sun is concerned. There is a very interesting feature that is observed on the sun that is referred to as sunspots. So these are regions of gases on the surface that are almost 1,000 degrees, almost 1,000 degrees cooler than the surrounding region. And there is an increase and decrease in the sunspots in a cycle every 11 years. It is because of this cyclic changes in the appearance of sunspots that we have been able to gather and analyze a lot of information about the details of the behavior of the sun, about the changes that are taking place in the sun. One of the interesting features that we have learned is that the sun takes nearly 25 days to complete one rotation about its axis through the observed periodic appearance of the sunspots. Then we have been able to realize that we can think of the sun as made up of a number of layers. We think of the sun itself as made up of a number of layers, and then we think of the solar atmosphere that also is made up of a number of layers. So we now talk of mainly 4 layers in the body of the sun. The outermost layer, that is referred to as the photosphere, so that forms the visible part of the sun. The temperature of this has been estimated to be nearly 6,000 degrees Celsius. Here it is interesting to note that this estimation of the temperature of the sun, this has been done by making use of a very, you can say, significant law that was discovered in connection with the behavior of black bodies here in the Earth laboratories, that is referred to as the Stephen-Boltzmann law. On the basis of that, the total amount of energy released by the sun overall per second, that was estimated, and on that basis one could say estimate how much energy the Earth will receive per unit area per unit time. That is something that we can measure here on the Earth. So measuring that energy, we can then calculate what should be the temperature of the sun, and the temperature of the photosphere of the sun, this has been estimated to be nearly 6,000 degrees Celsius. The layer immediately below the photosphere, this is known as the convective envelope. And then there is, of course, the radiation zone, through which the energy that is being generated in the inner parts of the sun, that is conveyed to the convective layer, and then of course it is released into space. The innermost layer is the core, and that is where the nuclear furnace, that is where the fusion of hydrogen into helium is taking place. So through the convective envelope, through the radiation zone, that energy is transferred through the photosphere to the outer part of the sun. Then we talk of the sun's atmosphere. So this also has been divided into several layers. There is the reversing layer that is immediately above the photosphere. So you have the sun's surface, and then of course you have the, you can say, layers in the atmosphere. So the layer that is immediately above the photosphere, that is referred to as the reversing layer. Then we have the chromosphere. So that is made up mainly of hydrogen gas. That is the next layer, and its reddish light can be seen during the eclipse of the sun. Then of course you have the corona. And the corona, of course, presents a beautiful and fascinating sight, of course, observed under carefully, you can say, taken precautions during the total solar eclipse. And we have had occasions to observe this brilliant appearance of the corona during a total solar eclipse. So the sun's atmosphere, that is also divided into a number of layers. Then the sun shows some very interesting properties in terms of solar winds and solar flares. The sun is continuously giving about 1 million tons of material in the form of streams of electrons and protons. This is referred to as a solar wind. So here we have some sort of a picture. When the charged particles constituting the solar wind, they are able to interact with the atoms of the Earth's atmosphere, then they produce very brilliant lighting effects. So these lighting effects are illustrated over here. They are observed near the North Pole and the South Pole regions of the Earth, and the Earth's magnetic field also has an important role in the appearance of this. Here what we have to remember is that the appearance of light, visible light or any other form of radiation that we think of, that is in terms of our theories, present day theories of the atom, that is thought of as resulting from the transition of electrons within the atom from a higher permitted energy level to a lower permitted energy level. When the atoms of the gases present in the atmosphere, the electrons in them receive energy through collisions with extra, you can say, outer charged particles, then they can get transformed to higher energy levels, and when they make a transition back to the lower energy level, we get this appearance of light. So near the Earth's poles, because of the Earth's magnetic field, this effect is most prominent, and we are able to see these very interesting lights because of the charged particles that are coming to the Earth's atmosphere from the solar winds and the solar flares. The solar flares are a very dynamic activity on the surface of the sun and the atmosphere of the sun. So when there are solar flares, then they release a tremendous amount of charged particles, and this results in a, you can say, disruption of communication as far as that is being observed on the Earth. So it is through these observations that we have been able to get detailed information about the solar flares and the solar winds. Okay, having talked a little bit about the sun, the central member, now let us look a little bit about the different planets that constitute the solar family. The nearest family, of course, the nearest planet is the planet Mercury. Now this has a very interesting feature that its period of rotation about its own axis and its period of revolution around the sun, they are not very different from each other. So therefore it presents almost the same side to the sun all the time. So therefore one side of this planet is very hot and the other side is very cold. One would expect that because Mercury is closest to the sun, that must be the hottest planet, but that is not strictly the case. It is one side of Mercury that is very hot. The other side, of course, becomes very cold because that always stays away from the sun. Mercury is characterized by another interesting feature, that it has no atmosphere and no satellite of its own. It is a very small planet and is seen fairly rarely in a morning just before sunrise in the eastern sky and in the evening just after sunset in the western sky. So we are not easily able to observe it because of its smallness, because of its closeness to the sun. The next planet, of course, is Venus. So that is the planet nearest to the Earth. And this is the third brightest object in the night sky after the sun and the moon. Very interesting feature of Venus is that, like the moon, it goes through phases, but of course its phases take a much longer time to be observed and analyzed in detail compared to the phases that we see for moon. It takes almost 20 months for Venus to complete one phase. Venus is not nearest to the sun, but because of a very interesting effect known as the greenhouse effect, this becomes the hottest of all planets. The greenhouse effect is something that we are all talking about at present, because that is believed to be presenting some sort of a real danger of global warming, and that may lead to a lot of changes in our environment, in our living conditions, in the condition of the earth as a whole. And as we know, the greenhouse effect basically means that you have certain, you can say, media through which radiation can enter. But once a part of energy of that radiation has been absorbed and you have a radiation of lower energy, it cannot escape from that particular media. So the energy gets trapped, and that is what we refer to as the greenhouse effect. Here it is the carbon dioxide gas that has been observed to be the most prominent cause of the greenhouse effect, and the presence of carbon dioxide in the Earth's atmosphere, that is of course important in keeping the Earth warm and at the temperature that makes life possible on it. But as we are now experiencing, if we have a continuous increase in the content of carbon dioxide, that may lead to an increase in the greenhouse effect, and that is what will cause global warming, which can have very, you can say, far-reaching and probably disastrous consequences. As far as the planet Venus is concerned, because its atmosphere contains a lot of carbon dioxide gas, there is a lot of greenhouse effect over there. That is why the heat of the sun gets trapped between the surface of the planet and its atmosphere, and because of this reason that Venus becomes the hottest of all planets. The temperature of Venus is much higher than what is there on the hot side of Mercury. So there is as much as 96% of carbon dioxide in the Venus atmosphere. The atmospheric pressure of Venus is almost 90 times that of the Earth. So that of course makes it a very, you can say, hostile or inhabitable planet. It is very hot, it has a tremendous pressure, therefore the conditions as for the life known on the Earth, they are not favorable. But people are thinking in terms of a number of, you can say, alternatives, possibilities through which maybe in some distant point in time Venus may become a habitable planet. What is being suggested is that we may somehow be able to transport some sort of very tiny organisms on the planet Venus. The organisms should be such that they are able to take in carbon dioxide and release oxygen. So if that process continues for a long period of time, then the content of carbon dioxide that can decrease, the content of oxygen that can increase, and then maybe of some distant point in time the conditions may become such that life, at least in some primitive form, may become sustainable on the planet Venus. But at present, of course, the conditions, very high temperature and very high, of course, you can say, pressure, makes Venus not the kind of planet where life is likely to exist. The next planet on the other side of the Earth, as far as the distance from the Sun is concerned, we have Mercury coming the first, then Venus, then Earth, and then on the other side of the Earth we have the planet Mars. And that of course is considered as a very interesting planet in the sense that people have reason to believe that the conditions on Mars are such that that becomes perhaps the most likely candidate where life may originate and may sustain itself. So this is a very Earth-like planet that is our closest neighbor after Venus. It has a 24-hour day, experiences summer and winter seasons, each of which lasts for 6 months. The season changes are, however, more extreme compared to the seasonal changes that we have here on the Earth. But because it has a 24-hour day, it has a seasonal changes, so this makes it somewhat similar to the Earth. So there has been for quite some time speculation about the possibility of life being on the Earth. But as far as the evidence at present is concerned, we do not have any, you can say, very definite or concrete reason to believe that Mars will be having or has some form of life on it. So that appears something that is not likely, the presence of life, but of course there are some evidences that indicate that some sort of primitive life may be existing on Mars. So this has been a planet that has been very intensively investigated and mapped, and the investigations have been done through satellites sent into orbits around the Sun, to, you can say, automated laboratories that have been made to land on its surface, the Viking space probes that have been used to know the details of this. What we know now is that this has a very thin atmosphere that has nearly 95% of carbon dioxide. The atmospheric pressure, however, is very low, comparable to that at a height of 32 km above sea level. So you know that with every kilometer the pressure on the Earth's surface goes down by a considerable factor. 32 km above the Earth's sea level, the atmospheric pressure on the Earth will be very, very low, almost negligible. So that is the kind of atmospheric pressure that we have on the Mars. Mars surface temperatures varies from nearly 21 to 27 degrees at noon to as low as minus 84 degrees during the night. This has two natural satellites of its own. So because of these similarities, Mars is something that is being investigated in detail, and maybe future investigations may give us some more clues about the possibility of some sort of life being there on the Mars. Then before the next or the first of the Jovian planets comes into picture, we have a very, you can say, large collection of tiny objects between the orbit of Mars and Jupiter. So that is what is referred to as the asteroid belt. Very large number of asteroids are in the about 547 million kilometer gap between the orbits of Mars and Jupiter. So they are believed to represent original solar material that has failed to combine together to form itself into a planet. You know that the origin of planets is believed to be through the collection of solar material or gases combining together under the force of gravitation. Here the asteroids are believed to be material that got fragmented, that could not come together under the gravitational force and form itself into a planet. So there are very large number of asteroids, but the largest asteroid is what is called the Cirrus. And this was discovered in 1801, and this is almost of the status of a dwarf planet. Asteroids are of course irregular in shape, and they have varying amounts of light falling on them. They have varying amounts of mass. Sometimes their fragments, they enter the Earth's atmosphere, and then when there is a lot of friction between these fast moving objects and the Earth's atmosphere, we get brilliant streaks of light. So they are what we refer to as the meteors, and some of these fragments sometimes are large enough that they do not get vaporized because of the intense heat produced by the friction with the Earth's atmosphere. Some of them are able to reach the Earth's surface, then they are referred to as meteoroids, and the meteoroids provide us some sort of, you can say, a direct piece of solar material through which a detailed investigation enables us to find a lot of, you can say, details about the structure of the materials that are forming the different planets of the solar system. So chemical analysis of meteoroids provides vital information about the solar system. The number of known asteroids now runs into thousands, and that is only some of them that are large enough. The others are very tiny objects, but they are primarily present between the orbits of Mars and Jupiter. Now let us talk about Jupiter. Jupiter, of course, is a very interesting planet in the sense that this is the largest of all the planets of the solar family. So its mass is more than double the sum of masses of all the other planets taken together. The gaseous atmosphere around it is made up of hydrogen and helium with significant amounts of ammonia and methane. In fact, there are reasons to believe that had Jupiter gone a little up in terms of its mass, the resultant gravitational contraction might have resulted its core to acquire temperatures that could have caused nuclear fusion to start in it, and then it could have started emitting light of its own. Now this is believed to have a large metallic core which at the center is likely to be a small rocky core whose temperature may be as high as 20,000 degrees Celsius. There is a very interesting feature of Jupiter that we see over here, that is the great red spot. So this was something which has been a matter of speculation and puzzle for astronomers for a long time, but the Pioneer and the Voyager missions, they have revealed that the red atmosphere, the red spot, is a large cyclonic disturbance in the atmosphere of the Jupiter. Jupiter is, as I just mentioned, because it is very massive compared to all the other planets, this is something which had the possibility of emitting light of its own, and therefore this is considered as being closest to the Sun as far as the various planets are concerned. So the large mass of Jupiter almost brought it to the threshold of emitting light of its own. Though it falls short of that, it is believed to emit relatively small energy radio waves of its own. This has very large number of satellites, and the number of satellites that are being discovered about Jupiter with more and more, you can say, probing radio and optical telescopes, that number is continuously increasing, and at present the number is believed to have gone up to as much as 62 to 63. But the earlier satellites, the largest satellites of this planet, they were something that were observed by Galileo using his very, you can say, primitive and imperfect telescope. And it was this observation that we have already noted is one of the reasons why we gave up the idea of a geocentric system and we talked of a heliocentric system. Jupiter's present day conditions are somewhat similar to those on the Earth about 4 billion years ago. So that of course opens up the possibility that just as in a time span of 4 billion years, the Earth has evolved into a state where life is able to originate and is able to sustain itself on it, and a period of time, maybe conditions in Jupiter may also change to an extent that it may also be able to have some sort of life on it. So that will lead us to realize that life no longer is an exclusive feature of Earth, but is a universal phenomena that may be present throughout the universe. But that is of course mere speculation at present. We do not have any concrete evidence of life in any form similar to that on the Earth being present anywhere else on the solar system. Then we talk of the next Jovian planet, Saturn. Saturn, is characterized by this system of rings that are available around it, and this was the last of the planets that were observed without the use of the telescopes. So this is the second largest planet of the solar system, and this of course is characterized by its unique system of rings. This is one of the very beautiful sights in the solar system, and this is colder than Jupiter because it is farther off than Jupiter. Temperature is very low. Saturn, like Jupiter, this is made up mainly of hydrogen and helium with traces of ammonia, methane and other compounds. The rings of Saturn, they are now believed to be made up of large amounts of solid matter, particularly probably ice coated rocks, because the temperature is very low, so things could freeze themselves to what we can call some sort of a ice. And then Saturn has a very large number of satellites. Jupiter, as we have just noted, has a very large number of satellites. The number at present some people have estimated to be around 62 to 63. Saturn also has a very large number of satellites. The number estimated for the number of satellites for Saturn is as large as 33 at present. The largest of these satellites, the Titan, is so much large in diameter that it could be considered almost as a planet in itself. The atmosphere is nearly as dense as that on the Earth, but it is made up of 90% nitrogen gas and organic compounds such as HCN. Surface temperature of Saturn is very low, that is minus 184 degrees. Low temperature and presence of highly poisonous gases like hydrogen cyanide almost rules out the possibility of the life form of any form of life that we know on the Earth as being there on the planet Saturn. Then we have the two planets that were discovered through the use of the telescope, the planet Uranus, and then of course the Neptune. So Uranus was the first that was discovered through the telescope. It appears as a green disk with vague markings. The color is due to the large amounts of methane and ammonia clouds in its outer atmosphere. The temperature of its ammonia clouds is very low, as low as minus 217 degrees Celsius, and is made up mainly of gases such as hydrogen, helium and methane, just like Jupiter and Saturn. But this planet has a very unique feature, that its axis of rotation is tilted at 98 degrees to the perpendicular and lies almost in the plane of its orbit around the Sun. So it is considered as some sort of a toppled over planet that is rolling along the orbit like a wheel. The Sun therefore shines almost directly on its poles because it is a rolled over planet. So the Sun shines almost on its poles, and a very large number of satellites it has. The number of its satellites that has been estimated to be as large as 27. The second planet that was discovered by using the telescope, that is the eighth and now regarded as the last planet. This was discovered in 1846 by this astronomer John Gale. The atmosphere has methane but has no detectable ammonia, and the cloud temperature is very low, minus 237 degrees. The satellite Triton orbiting Uranus is one of the biggest satellites in the solar system. So this orbits the planet in a sense opposite to that of planet's own rotation, that is in the clockwise sense. Nereid is another of its prominent satellites. The number of satellites of Neptune is now estimated to be 13. Let us now briefly talk about Pluto. Pluto was regarded as the ninth planet of the solar system. Now it is not being regarded as a planet but as a dwarf planet. This was because of the meeting of the International Astronomical Unit that was held in Prague on 24th August 2006, and that meeting certain criteria were laid down so as to regard an object as a planet in the solar system. Because of those criteria that we will just list down, we will find that Pluto does not appear to quite qualify as a planet. But as I just mentioned, there is a lot of debate and discussion going on about this, and maybe the International Astronomical Unit comes up with some sort of a, you can say, revised criteria for designating an object as a planet, and maybe we may again have Pluto being designated as a planet. But as present, the criteria that have been listed down for regarding an object as a planet is, so the object must be in an orbit around the Sun. It has to be large enough to become a sphere under its own gravitational force. More specifically, its own gravity should pull it into a shape of hydrostatic equilibrium. But then there is this third criteria: a planet must dominate the neighborhood in its orbit. That means if there are any other objects in its neighborhood in its orbit, this object must be much larger than these neighboring objects. Pluto does not fulfill the third of these criteria because it is not large enough in comparison to its satellite, the moon Cheiron. Another, of course, disturbing feature about Pluto that has been something that has been there long ago: its orbit crosses the orbit of Neptune. No other planetary orbit crosses the orbit of any other planet. Hence, earlier on it was also suggested that Pluto might just be a satellite of Neptune that has somehow managed to escape into an orbit of its own. But because of the fact that it does not dominate its orbit, because of the fact that it is not large enough in comparison to its moon, we now tend to regard it as a dwarf planet rather than a planet. So this debate was initiated around the year 1921 when the first Kuiper belt object has been given a number that was discovered. Further discoveries intensified the debate, and in 2006 the International Astronomical Union decided that Pluto should be relegated to the status of a dwarf planet rather than be regarded as a planet of the solar system. Now, having talked about the planets of the solar system, let us now talk of the other interesting object that is part of the solar system. They are the comets. So comets are believed to be present in the cold outer area beyond Pluto. They are mainly, you can say spare kind of objects, you can say low in density, very much spread out, and they are made up mainly of water, ice mixed with frozen gases, methane, carbon dioxide and ammonia. They are believed to be the relics of the early history of the solar system. That is why people are interested in studying them. Comets generally, once they are seen, they do not appear to reappear once again as far as the view from the Earth is concerned. But there are a few exceptions, particularly the Halley's comet, that is making its appearance at regular intervals of almost 76 years. So this was the planet that was, say, earlier on believed to be that was last seen in 1986, and comets were earlier on believed to be, because they were rarely seen, they were, say, indicative of some sort of, you can say, disaster coming on over here. Now we of course do not believe any such thing, and we think of them as just another member of the solar family. But then comets, because they are relics of the ancient past, they are believed to give us vital information about the member of these different planets of the solar system. Of course, the most important planet of the solar system is the Earth, and that has just the right conditions because of which life has originated and has sustained itself on the Earth. We have detailed information through which we now have been able to picture together the layers of the Earth. We have also been able to picture together how the Earth may have originated, how the life may have originated, and there has been a constant evolution of life. And because some people believe that that evolution process has not stopped, life may continue to evolve further. But that is something which is just a matter of speculation. And we have now reason to believe that the further evolution of life may not be that useful as the extent to which the evolution of life at present has made life in the form that we know as mankind to be over there. So we have to keep on waiting, we have to keep on adding to our knowledge of the solar system, and then of course our knowledge of the universe as a whole. And we will have reason to believe that as our instruments, as our theories improve, our understanding of the universe, that will also improve. The process is never ending and will keep on going on. So okay, we'll say finish at this point of time. Thank you.